Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video we will learn what RAG or Retrieval Augmented Generation is, why we need it and how it works. We will also create a chatbot using RAG. So let's start by understanding why do we need RAG. So large language models or LLMs have some limitations. The first one is that they lack access to specific information. So LLMs are trained on lots of general data from internet, right? But they can't access private or specific data. So imagine that you want to create a chatbot for your business, and in that case LLMs will not give you good answers because they don't know about your company data, your company's private data, right? Because they were not trained on your company's data. So this is the one problem with LLMs, that they can't answer correctly to your private data. And then the second limitation is they can't provide you up-to-date information. So once LLMs are trained, they don't get any new information. So if LLM was trained 3 months ago, it can't answer questions about anything that happened in the last 3 months, right? So in both of these cases, whether you need specific data or the latest information, we need a way to give LLM some extra information to improve their responses for these two limitations. So that's where RAG comes in. RAG lets LLM use external sources to give you more accurate answers on private data or specific data, and RAG also help LLM to stay current with the new information. So in short, we can say that RAG helps LLM use outside data. Outside data means the new data, the data on which LLMs were not trained on, the data which is totally new to the LLMs, like your company's private data or the latest information. So with the help of RAG, we can provide this external outside data to LLMs, and then they can work for our specific use cases. So let's see, how does RAG work? So let's break it down. Suppose you want to build a chatbot for your business. When user will input a question in that chatbot, for example, user asks what are your business hours, then the retrieval component, the chatbot will use a retrieval component to search an external database or knowledge source for relevant information. So in our case, for our chatbot, the pages of our website will be the external knowledge, and on the basis of the user's question, the retrieval component will try to find out that which piece of text from our website pages is likely contain the answer to the user's question, right? So for example, let's talk about our previous example only, when user asked about the business hours. So in this case, the retrieval component will search a business website and find a page with your business hours listed, okay? Then the next component is augmentation. What happens here is that the retrieved document are then used to augment the original query. This means the relevant information from the document is added to the input that will be fed into the generative model. As per our example, the relevant information from our website page will be combined with the user's original query, okay? And then the third component is generation. Here the augmented query is passed to the generative model, and the model uses both the original query and the retrieved information to generate the accurate response. So as per our example, the augmented query is fed into the generative model, which uses the specific information about your business hours to generate a precise response. And then finally, chatbot will reply to the user with the exact business hours based on the latest information from our website. So this is how we can use RAG to work with our personal data or the task specific data. Now let's see the practical implementation. Now let's set up an environment to run the RAG application. So the first step is to open Anaconda prompt, and in Anaconda prompt we'll write a command with the help of which we will create our environment. And this is the command. So I want to create an environment with this name, and the Python version I'm using is Python 3.10. So you'll conda create -n, then the environment name, and then the Python version which you want to use, and hit enter. After this command, you will have the environment. Now I am not executing this command because I already have an environment with this name. Next step is to activate the environment, and to activate the environment you will write conda activate and then the environment name. So this is my environment. Okay, after that we need to install all the required packages, and all the required packages I have in requirements.txt file. Let me show you that file. So these are the all requirements which we need, and these requirements are present in requirement.txt file. And guys, this is the folder rag_demo. In this folder I have all the files which we need for our today's class. One of them is requirement.txt file. Now we need to enter in this folder, and then we will install the requirements. So for that you will write first, it is in E drive, and then I have another folder in it with the name of this, and then we have another folder, the name is rag demo. Okay, so here is my requirements.txt file, and to install the requirements you will write pip install -r requirements.txt and hit enter. This will install all the requirements. Now we have our environment ready. Next step is to understand the basics. Once we understand the basics of rag, and then we will create our app. Okay, so for that I will use Jupyter Notebook. Now we will write our code over here. So guys, for our today's class we will build a chatbot for this company. This is a Victoria on Move company. This is a movers and packers company, and it is based in Australia. So for our today's tutorial we will fetch the data from this website, and then we will create an application using rag in order to create a chatbot for this particular website. Okay, so the first step is we are importing this module, this unstructured URL loader. With the help of this module we will load the website pages of this website. And then here in the URLs I have created one list, and in this I have pasted the URLs of 3 different pages of that website. So local removal is .html, index.html, and then this contact.html. So these are the 3 pages from where we will load the data, and then we will use rag to work with this custom data. Here we have defined the list. Now using this unstructured URL loader we are providing the different URLs to it. Then with the help of this load function we are loading all the URLs. Now our data is loaded. If you want to see the data, we can just print this over here. Let's print it, and guys, here you can see that the data is loaded, and we have document one. Right now we have one document for one page, so we have loaded 3 different URLs, so we will have 3 different documents. Okay, so this first document have this data, and see from here second document has started, and till here we have the data from second document, and this is the third document. Okay, so we have the data. In next step we will divide this data into smaller chunks. So guys, see here, now what we want is we have this data. Okay, we have this data like this. Now the next step is to split this data into smaller chunks. And why we want to split this data into smaller chunks? Because whenever user will ask a question to the chatbot, we only want to fetch that text from the website which is related to that question. So for that we are dividing this whole data into the smaller chunk, and every chunk will be of this size. For dividing our data into smaller chunks we are using this recursive character text splitter, and here in this variable we are calling the recursive characters text splitter, and then using this split documents, our data is presented where? In this data variable, right? Remember, here we have the data variable where we have loaded all the data from all the URLs. So we are providing that data to the text splitter, which is using recursive character text splitter, and we are splitting the data. And guys, if you will print this, you will see that you have total number of documents are 15 now. Right now over here we were having 3 documents because one document for one website, but once we divided our data into smaller chunks, then we have 15 documents. And if you want to see those 15 documents, you will just print the docs over here like this, and here you can see. So this is the first document, and then from here this is the second document, right? Then we have this third document, then after that we have this fourth document. So like this you will see 15 documents, and every document now have the data. This is a smaller document, and whenever user will ask a question, we will only pick that document which have the information which matches the user query the most. Now the next step is we have the documents now. Our documents are like, let me just print one document here. So we have the documents now, and this is the first document, and here you can see that we have data in English. But how computer understands the data? We need to convert this data into some numerical form, right? So for that we will use embedding. Embedding will convert the data into numerical representation. So guys, this, with the help of this OpenAI embedding, you will convert the text into numerical representations. And here I'm just showing you the first document. So we have total 15 documents. So for all the 15 documents, we want to convert the text into numerical representation, and that we are doing with the help of OpenAI embedding. And once you convert those text into numbers, numerical form, we will store those embeddings in a database, vector database, and the vector database which we are using is Chroma. Okay, create the embedding and then we store the embedding over here in Chroma. So how we do that? So for that we just need to write this one line. First, to this documents we are providing the docs. This docs, we have 15 documents. Okay, then we are applying OpenAI embeddings on it, this which will convert the text into numbers. Then we are storing those numbers into Chroma. Those embeddings are getting stored into Chroma database, vector database, and this is the variable which have all this task. So when you'll execute it, okay, see here we are getting error because we need OpenAI API key, and once you have the OpenAI API key, then you can use it. So how you can create the OpenAI API key? So to create the OpenAI API key, you need to sign up and log in openai.com, and then after that you can visit this page. Okay, so I'm continuing with Google. You'll continue, you'll log in here, and guys, here API keys, you'll see your API key over here. So suppose you don't have any API key generated till now, then you can click on this create new secret key, and then this is optional thing. You just click on this create secret key and you will get a API key. Just copy that API key. Once you copy that API key, you need to paste that API key in this .env file. This .env file, let me open it. Here, OpenAI API key, here you will paste that API key, okay, and save this file. Now you have the API key. Next step is to load that API key. So to load that API key, you will use this. we are using this load underscore dot env module. With the help of this, you can load all the environment variables which are present in dot env file, and we need to import this OpenAI module also. Now when you will run it, see the cell is executed. We have a vector store now, and this is what you'll get. This vector store folder you will get, and inside that you will get these two files. So that means embeddings are created, and those embeddings are stored in a vector store now, vector database now. Next step is this retriever. So guys, remember I have told you in the beginning that we have three components. First one is retriever. Retriever is responsible to retrieve that document which matches the user query, right? So let's say if user asks this question, what kind of services they provide, then out of these 15 documents, our retriever will pick those documents which matches with this question the most. And how we are matching, how do we perform this similarity or matching thing? For that we are using search type is similarity, and for knowing the similarity between the query which user asked and the documents, these 15 documents which we have, how we are knowing the similarity? For that we are using the cosine similarity. We will fetch out the 6 documents which are matching with the question the most. Okay, so here we are creating the retriever. How we are creating this retriever? We are using the vector store which we have created over here, where we have stored our embedding. So we are using that vector store as a retriever, and as underscore retriever you will use just this, and you can use any vector store as a retriever. So for our today's class, which retriever we are using? We are using the vector store, the Chroma database. We are using it as a retriever, and for knowing which document matches the user query the most, we are using the cosine similarity, and we are fetching the 6 documents which matches with the user query the most. Okay, and when you'll run it, this work has been done. And if you will see the length of this, just check the length of this, and you will see that we got 6 queries, 6 retrieved documents, because we have mentioned 6 over here. Next step is to use the large language model in order to generate the response on the basis of these 6 retrieved documents. So for that we will first call the LLM. So in my today's class we are using OpenAI LLM only, and this is how you'll call the LLM variable. OpenAI model I'm using, temperature 0.4. This means see, this value lies between 0 to 1. 0 means the most accurate response, with the more focused response, right? And when you set the temperature equals to 1, or the values which are closer to 1, that means the more random response, the model will be more diverse, and it will provide you more random results. So 0.4 is the I think this value is giving good results. And the max token 500 simply means that the output which model will generate, that output will not have more than 500 tokens, will not have more than 500 words. After that, when you execute it, then we have the OpenAI LLM, and we are using GPT 3.5 over here as a LLM, and we have stored it in LLM variable. Now we will write a code which will generate the response on the basis of user's query. For that, first I'm importing these modules, and in this system prompt, this prompt will guide our LLM on how to generate the response on the basis of the context. This context placeholder, this will get the data from the retrieved documents. The documents which, these retrieved documents which are matching with the user query the most, these retrieved documents will be used over here at the place of this placeholder context, and this system prompt will guide the LLM to generate the response on the basis of this context. Okay, then we have this prompt. Here we are creating a prompt using this chat prompt template. So this simply means this will show you the flow of the conversation of the user and the bot, and system means the LLM response we are getting from the system prompt, and human, this input placeholder is where user will fill the query, the question, the question which user will ask to the bot, that question will be entered over here in this placeholder. Now the next step is to create the chain. So to create the chain we are using this. So in this variable I'm calling this function create stuff document chain. So this function, the input parameter for this function is LLM, the large language model which we are using, OpenAI, and the prompt, this prompt. So this function have this data, and then in next line we are creating a chain. Over here we are providing the retriever first. Guys, remember the retriever is responsible here. Let me show you here. This retriever will first fetch out the documents which match the user's query. So whenever user will ask a question, the first thing will be to fetch out the documents which match with the user query. And once we have those documents, on that we are performing this question answer chain. This question answering chain, here LLM and prompt is passed, and then this will provide us the output. Now we have our chain ready. Now let's invoke this chain and see if this chain is able to answer the user's query. We are writing this dot invoke input. This is the question which user asked, and it is in response. Let's hit enter. See, this is the reply from our system, that Victoria on Move, this is the website, right? Victoria on Move provides local and interstate services in this. So see, this is the output which we get from our LLM now. So this is how RAG work. RAG will help your LLM with the external data. We provided the external data. Using that external data, LLM is providing the answers based on our personal data, based on our private data, right? So now we understood the basics. Now let's try to create an app. For that, we have this app1, this Python file. Let's open it. So guys, first I'm importing all the modules. So Streamlit, why we are importing this Streamlit module? Because we are going to create a Streamlit app, and for that we need this. And this OpenAI, you know that because we are using OpenAI model. So for that we need this module. Unstructured URL loader is required because we want to load the websites, and then using this we will split the website data into smaller chunks, and Chroma is a vector database which we are going to use. OpenAI embedding will convert the text into numerical representation. Then this will help us to create the chain, right? So all these things I have told you already, and using this line we are loading the environment variable. Which environment variable we are loading? The OpenAI API key, which is mentioned in .env file. And here with the help of st.title you will provide the title to your Streamlit app. So guys, let's run this code first and then let's understand this code. Okay, we were here. In this we have RAG folder, and then we have, and now guys, to run Streamlit app you write Streamlit run and then the app name. So this is my Streamlit app. This is a Streamlit app. Here we will write the question and we'll hit enter, and we'll see the answer over here. And this RAG application, this title we got with the help of this st.title. And then guys, this is the same list of URLs which I have explained you in Jupyter Notebook. Then we are loading it, and then using these two lines we are splitting the data into smaller chunks, and then we are converting those text into numerical representations and storing it into Chroma database. And then here we are using that vector store vector database Chroma as a retriever. Then we are using the LLM, and here st.chat_input. So this using this code we are getting this input box. Okay, so this input box, how we are getting it? By using this st.chat_input. And then this is the system prompt. Remember the prompt which I have explained you in the Jupyter Notebook. So context, what will be the input to this placeholder? The retrieved documents. And then we have this prompt, and then if query, if user asks a query, user enters a query, then we are running a chain, and then we are invoking the chain, and the input, which question we want to ask? The question which is present in the query variable. What is there in the query variable? The data whatever user will write in the input box. Okay, that will be the input to this chain, and our chain will show us the output for that particular query. And then we, using this st.write, we are showing that response on the screen. So now let's ask a question to it. So I've just written few questions over here, so let's just copy the question from here and paste here. For what all states they provide interstate moving services? Hit enter. See, we will provide interstate moving services for Melbourne to Sydney, Melbourne to Brisbane, Melbourne to Adelaide, and Melbourne to Canberra. And if you'll visit their website, here you can see Sydney, Melbourne, Brisbane, Adelaide, and Canberra. And that's what we are getting here. Now let's ask next question. Now I'm asking, provide me the contact details. So this is the contact detail of Victoria on Move. Next question is, let's ask this question now. Do they provide local moving services? Here, yes, they provide local moving services in Sydney. They also offer interstate services. Okay, so this is how you can create your own chatbot for your own business using RAG, and the GitHub link is mentioned in description section. You can get this code from there and you can try this code. And guys, I hope this video is helpful. So if my content is helpful, please like, share and subscribe my channel. Thank you for watching.